Hello, welcome to our project. Our project is about the pet feeder using the Arduino board and other electrical components to make it the pet feeder. So, next slide. This is our group member, myself, Nonthapat Liprasoetphan.
And my name is Sanispong Leelahasilp. Let's begin with the first one, which are project overview. In this project, the objective of the project is to build a system that can feed pets such as cats or dogs automatically without human intervention. This is particularly useful for pet owners who may be away from home for extended periods but still need to ensure their pets are fed regularly. And next is component that we use. First one is Arduino Uno. Second is servo motor. Third is 16 x 2 LCD display. Fourth is real-time clock model. We use DS1302 RTC. Next one is push button, breadboard and connecting wires, power source, 4x4 metric keypad, and the last one is resistor.
So the next one is functionality. The first function is user interface. In this project, include a user interface with a push button and also 4x4 metric keypad. This allows the user to set the feeding schedule and set the password before setting the pet feeder. The second one is real-time clock or the RTC. An RTC module is used to keep track of the current time. This enables the system to dispense food at a specific time set by the user. The third one is the servo motor control. A servo motor in this is employed to dispense the pet food. The motor is controlled by the Arduino board based on the programmed feeding schedule. And the fourth one is programming logic. The Arduino board is programmed to read the current time from the RTC module and compare it with the present feeding schedule. When the scheduled feeding time arrives, the servo motor is activated to dispense the appropriate amount of food. And the last one, LCD display feedback. The LCD display provides feedback to the user, indicating the current time and scheduled feeding times. And then the next slide. So in this slide, we will talk about significant and potential application of this project. The first significant is that the convenience of the pet owners. The project addresses a common concern among pet owners who may need to leave their pet alone for extended period, maybe due to work or travel or other commitments. It provides a convenient solution to ensure that pets are fed at a regular interval without the need of human intervention. The second one, pet health and well-being. Regular feeding schedules are essential for maintaining the health and well-being of the pet. By automating the feeding process, the project helps prevent underfeeding or overfeeding, ensuring that the pet receives the right amount of food at the right times. The third one, potential for commercialization. This project has the potential for commercialization as an affordable and accessible solution for pet owners worldwide. Manufacturers or entrepreneurs could further develop and refine the design for mass production, catering to a growing market of pet care automation products. And the fourth one, integration with the smart home system. Nowadays, the IoT is very common in our daily life with advancement in IoT or Internet of Things technologies. The automatic pet feeder can be integrated with smart home system or mobile application. This would enable remote monitoring and control notification and data analytics for the pet feeding habits. The last one is application in veterinary setting. Automatic vet feeder can also find application in veterinary clinic or the shelter, where multiple pets need to be fed at the specific times. The system can help streamline feeding routine and ensure consistency in pet care. The next slide.
And the next one is relevant theoretical background. So the first one is microcontroller programming. Proficiency in C or C++ for Arduino, including understanding digital analog input-output, loops, conditionals, and functions. These enable programming the microcontroller to control feeding, schedule, and respond to user input. Second one is electronics basics. Understanding fundamental electronics concepts like circuitry, voltage, current, and resistance. This knowledge is crucial for connecting and operating components such as motors, servos, sensors, and relays effectively. The third one is mechanical design. Knowledge of mechanical principles such as motion, force, torque, and friction. This is essential for selecting appropriate motors, servos, and designing feeder mechanisms that operate reliably and accurately. Dispense pet food. Fourth one is power supply. Awareness of power requirements and selection of suitable power source, whether battery or main power. Additionally, considering energy efficient designs can extend battery life or reduce electricity consumption. Fifth one is sensor and feedback. Familiarity with various sensor types like proximity sensor or motion detector. Integrating these sensors enable the feeder to respond to external stimuli, ensuring timely and accurate dispensing of pet food. Feedback mechanism help ensure the feeder operates as intended and can detect and respond to errors or malfunctions. And the last one is safety consideration. Understanding safety measure to prevent electrical hazards. For example, short circuit, proper insulation, and mechanism hazard. For example, trapping, ensuring the feeder is safe for both pets and user is paramount throughout the design and construction process. Next one is our circuit that you can see from here, and the explanation is in this Arduino based automatic pet feeder designed to ensure your pet is fed on time every time. Central to its operation is the DS1G02 RTC or real-time clock module, which allows precise scheduling of feeding times by configuring the device to align with your pet's eating routine. It will autonomously dispense food into the bowl. Our setup includes a 16-time tooth LCD to exhibit the time closely of the DS1302 RTC module, paired with an Arduino Uno, a servo motor facilitates force distribution by rotate the container, while a 4x4 metric keypad enables manual adjustment of feeding schedule, customizable rotation angle, and container opening. Duration cater to vary the food quantity so to your pet need, be it a dog, cat, or bird. And we also add the password to open the process by using 4x4 metric keypad. And the next one
is so the next one, this is the program flowchart. So our flowchart starts from the start function, and then we go down to the enter password part. If we choose to enter the password, it will check on the right that the password is correct or not. If the password is not correct, you have to enter the password again. But if the password is correct, you can set the feeding schedule and then continue to the read current time from the RTC. And on the left part, if you didn't enter the password, the program will automatically go to the read current time from the RTC too. And then after that, it will go to the check feeding schedule. And then after that, activate the servo motor and then update the LCD display and go to the end process. The next slide is rationale. First, enter password. The user is prompted to enter a password to set the feeding schedule. If a password is not entered, the system checks if it is correct. If the password is correct, the process continues to set the feeding schedule. If it is not correct, the system prompts the user to enter the password again. However, if no password is entered, the process proceeds to reading the current time from the RTC. The second one of the rationale, set feeding schedule. The user enters the time they want to set a time schedule for the feeder, then proceed to reading the current time from the RTC. The next step, read current time on the RTC. So the program reads the current time from the system clock or real-time clock module that we use to keep track of the time for the feeding schedules. The next one, check feeding schedule. The current time is compared against predefined feeding schedule to determine if it is time to dispense the food or not. The next one, activate servo motor. If the current time matches the scheduled feeding time, the servo motor is activated to dispense the food on the bottom of the machine. And then the last one, update the LCD display. The LCD display is updated to show the current time and also the next scheduled feeding time and any relevant feedback message. Next one. Next one is our budget that we use. In this project, we estimate rate using 100 baht. We use this money for the cardboards and the bottle as the containers. And last one is a bowl. Why we spend only 0 baht for all of the auto equipment? Because we already have all something it is provided in the lab room. So we didn't have to spend any money on the equipment.
And the last topic is expect learning outcome from the project. So in this project, we will learn how to use Arduino to control things like motors and display. They will also figure out how to put electronic and mechanical parts together to make a pet feeder by customizing and fixing any problem. They will make sure the feeder works well for their pet and learn more about how pet behave. We will develop skills in Arduino programming, electronic integration, and mechanical assembly by customizing the feeder and troubleshooting any issue. We will gain a deeper understanding of pet behavior and how to cater to their needs effectively. So this is our project proposal. Thank you for your attention.